relationship between them is a containment relationship. Each device will form a database like this within the same area. LSDBs of all devices are consistent. We tend to say it's a barrel because everyone's buckets contain the same things, including what equipment is installed. Generated information are consistent in the end. We also call maintaining an identical bucket. Let's take a look. It's actually very similar to the one I just drew. There are 3 devices. They all generate a lot of LSA. So now each device is flapping each other. Each device learns from other devices. It's called database. This database belongs to each device. That is, RA, RB, and RC each have one. And the databases in them are the same. It also looks like a barrel. For a device, it just needs to have all the information. Then it can be based on the SPF algorithm. Calculate the number of shortest paths. This is what we call the shortest path. Each device counts as one. For example, this is RA. This node is A. Then it goes to RB or RC. Then it counts the number. Then go to route calculation. Only then can the routing table of the device be calculated. Relatively speaking, the principle is very complicated. At the NP stage, you will also learn how to draw this picture based on what we've shown. Neighbor appearance or LSA appearance. Invert this graph. So now we have to think about a question. LSAs generated by each device. How did it get into the LSDB of other devices? That is, R3 now has to give R2 pass. Then that's the problem. Like we do in real life. You want to tell others about yourself. Then you two have to get to know each other first. Equipment as well. The device now wants to pass information to other devices through OSPF. Then the two of them must first get to know each other in OSPF. Just like EIGRP. So you have to make sure, before the device forwards the LSA, the two devices must first be aware of each other. They are going to establish a relationship with each other. Also called neighbor relationship in OSPF. It's just that there are 2 relationships. A neighbor. Adjacency. Whether neighbor or adjacency must ensure that the device can establish this relationship. They will be able to perform the next sync. If this relationship cannot be established, then they cannot be synchronized. So I will summarize the process of OSPF for you. The first step is to establish a relationship. The second step is to synchronize the LSA. After that, build LSDB. After building, the device will start to calculate the route through the SPF algorithm. So for OSPF, its process is relatively complicated. Devices need to establish a relationship with each other. Second, synchronize LSA. Build LSDB. The third step will be performed after the construction is completed. This is its process. You will focus on learning this in the NP stage. We will learn today how to build relationships. Actually, this corresponds to the 3 tables in OSPF. Neighbor table, database table, and routing table, corresponding to 3 steps. Let's read it together. In fact, most of the content we have already said. First, the neighbor table. There are some key parameters in the neighbor table, such as neighbor ID. This ID is the identity. Then the neighbor ID is the same. What it sees is not its own, because it is R1. Wait a minute, we must configure R1 to be 1.1.1.1. Everyone knows this. So 2.2.2.2 appearing here must be from other devices. Is R2. This is called the neighbor's router ID. Below this has a priority. Then this priority refers to the interface priority. That is, now R1 and R2 establish a neighbor. Then the OSPF relationship is also based on the interface. You will learn later that the division of regions is also based on interfaces. The establishment of the relationship is also based on the interface. We sometimes declare network segments. In fact, it is to declare the network segment where the interface is located. In fact, we are still declaring the interface. That is, now the two interfaces establish a relationship. Because the interface is in the network segment. So we say it is to declare the network segment. You need to understand this concept. This priority refers to the interface priority. Look down. Here is a state called full DR. The interface priority depends on the priority of the peer. The neighbor of the device is 2.2.2.2. Neighbor's interface priority is 1. This full is the neighbor status. This DR is the interface status. It's all neighbors. Further down here is a dead time. For OSPF. There is also a hello packet. EIGRP also has hello packets. It's just that it is sent every 5 seconds. 15 seconds to declare death. OSPF sends once every 10 seconds. 40 seconds to declare death. So the 39 you see here is a countdown. Now the two devices send hello packets to each other. Send once every 10 seconds. As long as the device receives the hello packet sent by the peer, it will reset this to 40. Then start counting down until it reads 0. If the peer does not send a hello packet to it, then this neighbor is gone. Let's look down. Here is an address. This is the IP address of the neighbor interface. The device interface is 192.168.1.1. The neighbor interface is 192.168.1.2. And the last, interface. This is the interface used by the device to establish a neighbor with the other party locally. Only this is the device's own. The device uses its own local 10 and its neighbors. That is, the previous parameters are the parameters of the neighbors. Only the last one is the parameter of the device itself. Let's look at the OSPF database next. For the database, there are all kinds of LSAs in it. We won't talk about this stuff now, so everyone simply understands the concept. Further down is the routing table. We are actually very familiar with the routing table. First of all, O means that the above is OSPF. Sometimes you may see OE2 here. OE2 means this is an external route. That is, the redistribution comes in. Remember redistribution? The left side of this device is EIGRP. On the right is OSPF. Then I wanted to learn the routes learned by EIGRP here. I'll redistribute it in. Called routing. Also known as route redistribution. If it is like this. If there is a 1.1.1.1 route here, a 1.1.1.1 route will appear in the routing table. OE2 is a representation in Cisco. Let's talk about the last. Is some theory of OSPF. Administrative distance. The external is the redistribution I just mentioned. Then you will find, in Cisco, the overall management distance inside and outside OSPF is repeated. Then if we do heavy division in the future. In fact, in some cases it will cause